Hello, my lovely psychology students. This session in research methods, we're going to start with a slight introduction into inferential statistics. Now, in research methods, we've already looked at descriptive statistics, and these are types of statistics that allow us to describe what we have found. Now, that can be your measurements of central tendency, your measurements of dispersion, graphical display, so your different types of graphs. They describe the findings. With descriptive statistics, we cannot make a solid conclusion of whether our research actually proved our hypothesis or not. That's why we need inferential statistics. These are the statistics, which we have lots of different types of tests that we'll look at over a period of time. And they allow us to do certain mathematical calculations to see whether we can accept our experimental or alternative hypothesis and reject our null, or vice versa. So these are the type of statistics that allow a researcher to make solid conclusions, whether they proved what they set out to prove or they didn't. But before we start getting into those, we're just going to introduce you to some basic terminology that you need to start to become familiar with. So let's look at a few key concepts along with this. Our first key concept is the term called significance level. Significance level means that the results are not occurring due to chance. They just haven't happened by luck. They've actually happened that when we find significance levels, that allows us to say, yes, our alternative hypothesis is correct. Now, there is a little bit more to significance level because we need to understand a little bit of the terminology of the maths behind. In this term, you're already familiar with probability. Probability is the numerical measure of the likelihood or chance that results will occur. You've done probability. If I had a coin, I would have 2 in 1 chances, so 50% chance or a 50% probability that I'll get ahead. You mean you've done this in high school maths, but probability is the numerical measure of the likelihood that or chance that results will occur. Now, we have probability levels, and it's important that you understand those. So what we mean, if the results occur, we need to be 95% correct, minimum. And that means we allow for 5% error, because nothing's perfect, even in science. So this means that the findings have to be a minimum of being 95% correct or valid, and only allows for 5% error. Only allows for that 5%. So if you were replicated a study 20 times, that means 19 of the times you need to get the same findings, but that one allows you then not to have one that doesn't have the same findings. You have found significance then, because you're 95% correct. And that can be represented in psychology. In the majority of sciences, you will find that probability or significance level is set at 5%. And that can come in different, we can write it as 5%, or P stands for probability, equals 0.05. And that is the equivalent of 5%. These will make more sense when we start doing the test, but it's just to get you to get your head around these concepts. So significance level, if we have found significance, and that means we have found that our results are 95% more, not less, are correct, then we found significance level. And that means if we have found significance, we will accept our alternative hypothesis and reject our null hypothesis. If we didn't find that our results were 95% correct, so perhaps they were 92% correct, we have not found significance because there's too much chance has occurred. So that means we accept our null hypothesis and reject our alternative hypothesis. Our next key concepts that we're going to be looking at is called the calculated value. It is also referred to as the observed value. So both of these mean the exact same things. You know how I like to give you the key terms that could be used for the same things. So the calculated value or the observed value literally means it's the value or it's the results that have been calculated by the researcher from using the data generated from their research. So, for example, if you were the research, you've done your piece of research, you've calculated all the data, and you get a final result. That is the calculated value or the observed value. It's the value from your calculations that you have generated from your research. So it's the calculated value, a very important value, because that calculated value needs to be compared to our next key concept, to the critical value. And we get these critical values from critical value tables. Now, these are preset values that you find in a pre-printed critical value table. And this one, the researcher does no calculations. It's the lovely statistical mathematicians who have created those. We then refer to them to see whether our own calculated or observed value is either equal to or greater than, depending on what the statistical test wants, to the critical value. So these are preset. Now, when you use this table, you need to remember that we only use the column that shows the level of significance at 5% or p equals 0.05. Please don't say it's not p equals 0.5, that's 50%, right? Because remember, probability is out of 1. So if we've got 0.05, that means 5%. So we need to, when we're using the table, make sure we've got the right column. Another thing that you need to keep in mind when you're using the critical value table is whether your hypothesis is a two-tailed or a one-tailed hypothesis. Two-tailed, non-directional, one-tailed, a directional hypothesis. Again, it's about choosing the right column so that we get the correct critical value from the critical value table, because then we need to be able to use that in comparison with our own calculated value. Now, just a few key terms to get you going, right, with regards to it. Nothing strenuous, get these into your glossary, add them to your notes, because these are some key terms that we're going to be using when we do our first inferential statistical test. Now, don't panic. The first test we're going to do is really pretty simple. Right, you'll be able to, once you've done it once, you'll be able to do it with your eyes closed. Well, obviously you've got to read the data, but it is quite straightforward, so don't panic there.